in the TCP/IP protocol stack, the transport layer is characterized by transport protocols. In fact, these transport protocols run in end systems like hosts. The transport layer itself provides a logical communication between the application processes that are running in these end systems. The most well-known protocols pertaining to the transport layer are the TCP and the UDP protocols. The TCP stands for Transmission Control Protocol, whereas UDP stands for User Datagram Protocol. In the following slides, we will go and see in more detail how TCP protocol works. The TCP protocol is defined by RFC 793. RFC is a request for comments. It's a formal standards document that is developed by the Internet Engineering Task Force. TCP is also known as a connection-oriented protocol. It is a connection-oriented protocol because the control messages are exchanged between the sender and the receiver before starting the process of data exchange. The information units that characterize TCP are called segments, and they are also characterized because they are numbered and they are composed of bytes of data. In fact, we can say that the TCP protocol is a reliable in-order protocol, or ensures a reliable in-order delivery because it keeps track of the unique ID of each of the segments which are being transmitted. In fact, one of the mechanisms that TCP implies is also the sending of positive acknowledgements. So when the receiver has correctly received the information sent by the sender, it sends back packets or segments to the sender saying that I have correctly received the information. It is also possible to deploy or to impose delayed acknowledgements, meaning that the acknowledgement is not sent for every segment, but instead for n number of segments. There are two main mechanisms that characterize TCP protocol, is the flow control and the congestion control. The flow control is characterized or represents basically the capability of the receiver to authorize the sender to send a certain amount of segments, because it tells the sender what is the current storage capability that it has in the buffer. On the other side, the congestion control refers to the fact that the sender can also adapt the transmission of the segments according to the current state of the network. If the network is more loaded, then the sender might be more likely to send a lower number of segments. Again, TCP protocol is defined as connection-oriented protocol because first it sets up the connection, then it sends the data that must be transmitted, and once the data has been transmitted, then it sends additional packets, additional information to tear down or to stop the connection. In fact, TCP protocol is characterized by the fact that it allows multiplexing via the socket. It allows in-sequence delivery. This means that the information units, the segments which are out of sequence that might be accepted in the receiver side, are not discarded, but rather kept. And the two other mechanisms that I discussed in the previous slide, the flow control and the congestion control. In fact, the TCP receives messages from the application layer. So we have the application layer that writes the data. These data are sent to the TCP buffer. Then the buffer basically will convert the data into segments. These segments are then sent towards the destination. And then the TCP receive buffer basically receives these segments and at a certain moment in time forwards them towards the application. In fact, the size of these segments might be variable depending on the state of the network. And TCP is also known for accumulating the received data in a buffer. It might be that the application layer does not have the capability of processing these data at a given speed, so the TCP will keep the information in a buffer. In fact, it might be that when certain conditions are met, the TCP will take a portion of the data and form a segment. Then the segment is sent out towards the destination. However, the segment size is quite critical for performance, so TCP has in place certain mechanisms that also ensure the way how the segment size is set. TCP has similarities with other protocols. In fact, it uses some of the mechanisms of protocols such as go back N, and it does so by implying or employing the numbering of the information units and the acknowledgement of the data received. In fact, we can say that TCP numbers each of the bytes that are being transmitted. In fact, it is important to note that the segments are a composition, are made up of a group of bytes. And in fact, also the window size, which identifies the capacity of the receiver to receive a certain amount of data, is expressed in bytes. The TCP segment header that we will see in the next slides also carries a lot of information, among which also the sequence number of the first byte to be transmitted. The receiver must in fact also acknowledge the received data by sending the sequence of the next byte that it expects. This way, it allows also the transmitter to keep track of up to what segment, up to what information unit has the receiver received, basically. So in case there is no acknowledgement for a given segment, and this acknowledgement does not arrive within a given time frame, within a given timeout, then data will be retransmitted. Now, going back to the TCP segment header, this is the composition of the TCP segment. In fact, it's composed of the source port, destination port, sequence number, acknowledgement number, and so on. Let's go and see in more detail what do these represent. The source and the destination port are relatively simple. They are 16 bits each, so it's a sequence of 16 bits, which identify the source and the destination port addresses. The sequence number is 32 bits, and basically is the sequence of the first byte in the payload, as I mentioned also in the previous slide. On the other side, the acknowledgement number is the sequence number of the next byte. So there is a correlation between the sequence number and the acknowledgement number, because the acknowledgement number is always the next byte which is expected to be received on the receiver side. Then we have the HLEN, which basically stands for the header length, which is 4 bits. This contains overall information on the length of the TCP header, since not necessarily the segment will be of the same length. Then we have the window, which is 16 bits, and basically contains the value of the reception window. This is important for being able to ensure a communication between the sender and the receiver, and also to understand what is the storage capacity of the receiver and how what is the amount of data that it can receive. On the other side, there is also the checksum, which basically allows to perform error checking the same way as it's done in the UDP protocol. Then there are the flags, so there are 8 fields. Each is long 1 bit, so it's either a 0 or a 1. That is the acknowledgement, the reset, synchronization, and finishing of the connection. In fact, the acknowledgement, in case is set to 1, that means that the packet is a valid acknowledgement. In this case, the acknowledgement number needs to be sent out so that you acknowledge the certain information unit that has been sent out. Then the reset button or reset bit allows to reset the connection. Then we have the synchronization, which allows to set up the connection between the sender and the receiver, and the fin flag, which basically allows to terminate the connection between the transmitter and the receiver. Then we have the options and padding. Basically, options is very important because it allows to communicate what is the maximum segment size. In fact, MSS is very important because it specifies what is the maximum or the largest amount of data, always expressed in bytes because we're talking about TCP, that a computer or a communication device can receive in a single TCP segment. And on the other side, the padding, basically it's padding to multiples of 32-bit, because in case that the length of the options field does not amount to 32 bits, then the padding is used to basically fill up the gap. So we saw the TCP protocol segment composed of various fields, which are strings of bits, each of them containing specific information, each of them allowing to have a reliable transport protocol that is characteristic for the TCP protocol.